Hello everyone, my name is Larionov. I am a student of Yaroslavl State University. Today I want to tell you about separation of closely located buildings on aerial images using unit neural network. Thousands of images of the Earth's surface are received from satellites every day. Nowadays, these photos are very high resolution with spatial resolution of 3 meter per pixel and better. For all of us, it's not problematic to observe contours of different objects on it. However, the problem of automatic segmentation on satellite images is challenging. In machine learning, segmentation is usually formulated as a pixel labeling task. Developed segmentation algorithms should satisfy the following requirements. Work with multi-band images, be invariant to rotation, take into account the small size of objects, cope with noise, separate closely located objects. This research, we developed algorithm based on convolutional neural network for building segmentation on satellite images. Since some buildings can be located very close to each other, they can be segmented as one object. So we modified developed algorithm to improve separation of closely located buildings. Unit was used as a basic network architecture. It has about 8 million trainable parameters. It consists of two parts, an encoder and a decoder. The encoder has the typical architecture of CNN and contains 5 blocks. The decoder contains the same number of blocks as an encoder. The last layer of CNN uses a 1-by-1 convolution to match each component vector to one of two classes, buildings and non-buildings. Since our images have 4 channels, we modified original unit by adding the second encoder for data from near channel, and both encoders are concatenated in the center. To improve separation of closely located buildings, we added the second decoder of the same structure to detect narrow borders. In the last stage, pixels, which belong to predicted boundaries, were reset on the segmentation mask. Developed CNN without information about boundaries was pre-trained on SpaceNet dataset. It consists of 4 channel aerial images with spatial resolution of 0.3 meter per pixel. All images have been sliced on paths of 256 by 256 size with the step of 188 by data windowing. The intersection of patches allows to cope with the problem of artifacts that appear at the junction of image fragments. After pre-training, our model was trained on Planet dataset. It includes about 1,800 images with spatial resolution of 0.7 meter per pixel. On the slide you can see example of image and corresponding mask. If the border between buildings on satellite images of Planet database did not exceed 3 pixels, this boundary was marked by red. To increase our dataset, we applied 3 stages of augmentation. It consists of rotation on 90, 180, 270 degrees and reflections. The training set increased 8 times after this stage. Chromatic distortions. Images were translated from RGB color space to HSV color space. Random values were added to HSV coordinates of images. For the near channel, instead of chromatic distortions, random values were added. And the third stage includes random shifts, scales and small degree rotations of patches. To estimate developed model, there were used dice coefficient of similarity, which shows the quality of segmentation, and F measure, which shows the quality of detection and separation of objects. The launch of the CNN was carried out on the supercomputer NVIDIA DTX1. As a numerical optimization algorithm, adaptive moment estimation optimizer was chosen. As a loss function, binary cross entropy minus dice was used. On every training iteration, the model updated its weights using the batch of 32 samples. The model enter is training after completed 100 epochs. In conclusion, the training process lasted about 2 hours. The dependency of dice coefficient on training epochs is presented on this slide. The highest value is 0.77. Here is presented a comparison of developed algorithm with classical unit and another method to improve separation of objects known as deep watershed transform. As we can see, proposed unit with the 2 encoders and 2 decoders shows the best results for both metrics. Here some test results are presented. Once more example. To conclude, it's claimed that CNNs can be efficiently used for building segmentation on aerial photos. Therefore, a unit with two encoders was modified by adding the second decoder for boundary detection. To evaluate the quality of developed algorithm, dice coefficient and F measure were chosen. After training and testing, the highest value of dice was equal to 0.77 and value of F measure was equal to 0.49. Regarding the future plans, we intend to try categorization of buildings based on area size and use the different encoders for every size. In addition, it might be useful to try another convolutional neural network known as mask-RCNN and more unit modifications. Now that's all. Thank you for your attention.